Hey folks, here's a super quick demo of Steamship's audio analytics package. From any programming language, this lets you pull in audio files and then query them for things like entity mentions, topics, sentiments, and interesting overlaps between all of them. There's no infrastructure to manage because everything happens in the cloud. So let's take a look at how you can do it. To try it out, all you have to do is type npx try-steamship audio analytics. And that will kick off a web OAuth flow if you've never used Steamship before. So just press enter to start that. I'll connect my email and password or Google account if I haven't already done that. It'll be completed. I close the browser. And now it'll ask, do I want to see a Streamlit demo on the web, which is cool and you could check it out, or the Python client demo. And that's what we're going to pick here. Now this will require that you have Jupyter Notebook on your machine. But if you do, you can just copy and paste this command. And that will open up an instance of Jupyter all set up for you to experiment with this package end to end. And it's quite a big notebook, so I'm not going to cover it in great detail, but I'll show you some of the high level bits. So we'll install Steamship here. I'll just shift enter my way down. And the first key bit to point out, I'll just call this Audio Analytics Client 99, and then we'll go back to explain what this is. You can think of Steamship as a virtual package manager. And so unlike, in Python where you say import foo from bar, or JavaScript where you say, require foo, first you instantiate the Steamship client, and then you use that as a virtual package manager to instantiate your package. And the reason we do this is so that we can manage all of the infrastructure for that package and the data context for that package in the cloud, number one. And number two, it lets us be cross-language. And so this lets us ship stubs to any language, and you can use the same packages from every language. So here what we're doing is providing both the package handle, so that's audio analytics, and then the instance handle, that's audio analytics client 99. And that makes sure that this instance of your package has all of its own isolated data storage, model storage, endpoint storage, everything under the sun. All right, so let's just dump out some metadata here, and I want to point out that in creating this instance of the package, you also get API endpoints. And so if you wanted to just call everything you see in this Jupyter Notebook as an HTTP client, you can do that too. All right, so the first thing we're going to need to do is submit some MP3 files for analysis. And so I'm going to kick that off because that's going to take a little bit of time. And then while I do, I'll go back and just show you what I've done. Right here, I just have a URL for a demo audio file that we've uploaded. Let's open that up. I think it's...
how about going to see her?
It's Teletubbies. We're a company full of dads, so we're filled with bad jokes and lots of cartoon files. What we've done is we've taken this audio URL here, and we're calling the analyze URL package analyze URL method on this package. Instance here is the instance of our package. Post is because it's an HTTP post. We give it the method name, and then we can just pass key WRX that get translated into JSON payload when we make that request. And so that gives us back an asynchronous task with a status. And down here, you can see that we are polling on it already. Now we're running in the implementation of this method in the cloud, audio transcription, entity analysis, sentiment analysis, what else? Topic detection, and then indexing all of that so you can query over it. So this is going to take a little bit of time. What I'm going to do is leave the screen running, and we'll just play it out. We'll fast forward the video so that kind of you see kind of all of it running continuously, and then I'll come back and pick up once it's done processing. All right, so that is, I believe, done. And let's go back and take a look at how we can look at some of the information in here. And so we have this file object. This object represents the file that we uploaded. And it now has a transcription that's also adorned with lots of metadata we can query. So to just give you an example, here is the first 1,000 characters of the transcription. Hello, hello, can I speak to Sally, please? Speaking, hi, this is Hannah, hi, Hannah, ... And this is the text, of course. But we can start to look at some of the additional metadata that we now have on top of that text. And so we have 161 distinct tags on top of that text across 7 unique features. So these features are timestamp, sentiment, topic, entity, speaker, chapter, and topic summary. So we can go in and query based on these and how they overlap and what kind of text they contain if we wanted to. And I'll show you some of the ways in which we can do that. Each tag that we're going to get back is going to look like this. So it will have a kind, that'll be timestamp, entity, topic. It'll have a name. For this particular package, we chose to have the name of the tag be the text that it subsumed. And then it will have a value. And so this is the timestamps, the start and end timestamps of the audio file that it covers. It also has a start index and an end index, and that's with respect to the transcript. And so using the tags that are going to come back from these queries, we can shoot to the place in the text, we can shoot to the place in the audio if you were building an app on top of this. So here's an example of the speaker tags. So we're just going to look through some of these. And here is one of those. So the kind is speaker, the name is A. We don't, of course, know the names, and so we have the diaterization labeling it A or B for this. We have sentiment tags. This is the schema of the sentiment tags we're going to get back. And we have a set of enum types, negative, neutral, and positive for the sentiment, and a confidence score on that. And the same here, we have the end time and the start time, that's in the audio file, and then the start index and the end index, that's in the text. And then entity, very similar thing. Kind, entity, name, Sally, start time, end time, start index, end index. And then these chapters, these are different. You can think of these as like segments of the audio text that it chunks up for us. Topics. This topic is family and relationships, parenting, daycare, and preschool, which is remarkably accurate. Given that this literally is a preschool audio. And it gives us the segment over which that overlaps. And then a summary. So here's an example of one of the summary tags. It says, the topic summary is food and drink, dessert, and baking. I actually don't know what this audio clip is about, and so I'm not sure if that's accurate or not. I assume it is. And when all of that is said and done, we can either enumerate through these tags, as we've been showing you the first of each here, or we can query them. So our query language and details of it is going to be forthcoming. It's one of the things we're really excited about at scale. So Steamship and Steamship packages give you the ability to throw in lots of data into one of our workspaces, run all these models on them, and then query the results. And the short version of it is, we have a query language which you can think of as a query language for natural language content. And that query language is based on the idea of text and tags atop that text. We use the name tag to just refer to some observation that can either be about all of the text or a region of the text. And tags can have names, and kinds, and they can also have values into which you can query as well. And so, for example, we could say, perform a query for tags of kind, entity, and the value with a value type of person, name. And if we do that, we'll find that there are 3 people referenced in this audio file, which is remarkably cool when you think about the fact that it took multiple models all annotating this audio file in order to produce the data that we just queried over. Now we can combine that with the sentiment tag. So let's find tags with the kind sentiment that have an overlap to entities with a particular kind of entity name, and we'll pick the entity name Kate. So here we find that there is a negative statement, Kate is sick, and a positive statement, Kate, here's an apple pie. I prefer the apple pie. We can do queries to find out who is spoken of in a negative context. And so kind entity and overlaps, kind sentiment and name negative. So this subquery here is finding all of the tags that have negative sentiment. And then this overlap query says we only want the intersection between that subquery and this entity query. And then here we're just looping over those tags that come back, and we print out the name of the tag. And so run it again. We get back Kate. We can, of course, jump into the audio fragments for one of these. And so this is kind timestamp and overlaps kind entity and name Kate. So now we're getting back tags about Kate. And then if we were to get the audio, we could say Kate is featured at the following timestamps in seconds, 59 and 21. And so let's just go to 59 and see if that's accurate.
Good.
Kate, here's an apple pie.
So
I made it for you.
There's Kate and the apple pie.
I like apple pie.
20 is here.
Hey, Hannah. What's up?
Kate is sick.
And there's Kate being sick, which is the negative sentiment.
That's too bad.
So the things we think you can do with this are just astounding. We're really excited. We think that where this is really going to help people is lots of folks want to build products, apps, experiments that interact with audio. But what you find is that doing something in a Jupyter notebook is easy to demo, but it's really hard to scale that into production. Everything you saw right here in this Jupyter notebook was happening in the cloud in a scalable way that you don't have to worry about managing the infrastructure of. So whether or not you're running in JavaScript, Python, C#, Ruby, all of this should still work. You can either use our Python client or you can use the HTTP endpoint that every one of our packages creates for you. And we would love to work with folks to build really interesting things that peek into the audio, peek into the video that their platforms are managing, and give users really interesting ways to interact with that. So please reach out to us. Again, all you have to type to try this out is npx try-steamship audio analytics, and that's it. Just press enter. It'll walk you through the onboarding. You can get this exact notebook that we were just playing with, and we'd love to chat with you about how you want to use it. Thanks a lot.